Okay, today we're going to be talking about differentiability. So I want you to make note of the drawings, the sketches that are on your screen, and go ahead and sketch those out on your notes. Alright? And hopefully you have enough time to complete this. We're going to go through this kind of fast. Alright? But it's very simple. A function is not differentiable at x equals c if any of the following conditions are true. Number one, the function is discontinuous at x equals c. So if you look at this example here, alright, so let's go ahead and take a look at this area right here. Well, notice what happens at this value of c. Okay, there's a jump, right? It's discontinuous. Therefore, it's not differentiable at this value of c. Alright, now let's take a look at the next one. Alright, it's kind of, oops, got a little crazy with my circles here. No, that's not good either. There we go. This function has a cusp, alright, a sharp turn at x equals c. So look at the cusp there, alright, at c. Look at how it curves up right there. It's sharp. Well, this function is also said not to be differentiable at that position, alright. And then the last case is that the function has a vertical tangent at the line x equals c. So take a look there. Notice the kind of vertical thing going on there. It's a vertical tangent. Alright? So what does it mean to be not differentiable? That means that we cannot take the derivative. Okay? Derivative and differentiability are the same thing. The derivative and differentiability are like I said, are exactly the same thing. So if we were to look at this function and we knew what any one of these values was, well, we'd find out, well, we can evaluate the derivative at that particular value of c, okay, or that particular value of x rather. Alright, so this is what we're talking about. So let's look at a couple examples here, and I think you should gain some understanding. So look at the first example. I've laid both of the sketches out for you to view. The first one says, sketch the graph of f of x equals 1 over x minus 3, and by visual inspection determine any points at which it is not differentiable. Okay, now we've spent some time talking about these rational functions and graphing them. You can verify this on your calculator, but notice what happens when x equals 3. We have a vertical asymptote. Notice the left-hand side goes down to negative infinity, and the right-hand side shoots up to positive infinity. So because of this asymptote, we have that discontinuity, and therefore our function is not differentiable at x equals 3. Okay? Now let's look at the next example. Sketch the graph of f of x equals the absolute value of x plus 2, and by visual inspection determine any points at which it is not differentiable. Okay, so this is what an absolute value sketch would look like. Notice it's just like the line y equals x plus 2, however it shoots off to the left when you get to the value of negative 2 for x. Okay, so there it is. There's our graph. Well, what can we say about negative 2? Well, let's flip back to the top part of our notes, and we notice that our function there kind of looks like this, right? A cusp. Alright? So let's go back over, and we should start seeing the cusp that's formed right in this area. Okay? So there's that cusp. Well, therefore we can state that it's not differentiable at x equals negative 2, and the reason there is because of the cusp that's formed. Okay? Let's take a look next at example 3 in our notes. So here's example 3. It says, sketch the graph of f of x equals 4 cube root of x, and by visual inspection determine any points at which it is not differentiable. Okay. Well, notice what I've done for you here. I rewrote this as 4x to the 1/3. Okay? That way I can punch it easily in on my calculator. So here's the sketch of the graph, and notice by visual inspection, where would it not be differentiable? Well, when x equals 0. Do we see the vertical tangent that's right in this area? Okay? So it's not differentiable at this value of x. Alright? So I hope this is pretty understandable, and you should be able to complete the attached assignment that goes along with your notes. We'll take a look at one more example in just a minute.